Okay, guys, we are ready to pick up on example C in this class, multiplying rational expressions. And if you recall from yesterday, before we multiply, before we simplify, it's all about factoring, right? So we have to be able to factor. So start by looking at x cubed minus 4x. What kind of factoring can we do there? Start with what?
You factor out the x, because both of them have an x, so you put an x, then you get a little parenthesis guy, then you get x squared minus 4, and then that turns into an x, and then another parenthesis, and then another parenthesis, and it's x plus 2 and x minus 2.
Whoa, what?
And that's your
just
top.
tell you I was way off.
Your top,
Okay.
your top guy.
Okay,
That's exactly what I had to.
I can follow that.
Okay.
Let's make sure everybody else follows.
Booyah!
Okay.
That's exactly what I had to
Now,
Give me some
Okay.
pin.
so first off, GCF, right? Both terms have an x. So factor out that GCF of x. Remember, don't lose the x. That x is going to be part of our answer or part of canceling later. One of the two. So keep the x. Now, you can finish this now or finish it later. Let's go ahead and finish it while we're talking about it. X squared minus 4. Is that done?
I don't think so.
No. It still factors more. And so I'm going to leave a space and come down here. X out front. We factored x squared minus 4 up on the very first example yesterday. X squared minus 4 is the difference of squares, right? So two parentheses. X and x. The square root of 4 is 2, so plus 2 and minus 2. Okay. Denominator. 6x squared minus 13x minus 5. Thoughts?
I could.
Let's start with, is there a GCF?
Oh, you gotta do product sum. No, there's not a GCF. Wait, yes, there is. There's not some. No.
Okay, so no GCF, but we always want to check.
Product with AC or whatever.
Okay, because there's an A value of 6, you need to think product of AC. So, I'm going to move this over here in the middle so we can review product of AC. Product of AC says I'm going to need a product of A times C. So I'm going to need a product of negative 30 and a sum of negative 13. Think carefully here. Product of negative 30, sum of negative 13.
3, maybe? No.
15 negative, yeah.
15, 2?
Yeah.
Oh.
Now, are you guys all smarter than me? No one did the 310?
Aaron was sounding like he was working on it.
Okay. So, now, here's just where you have to watch the signs, right? I'll be honest. If you look at my notes, I got a handful of whiteout on this problem because I started with 3 and 10.
Oh.
And in my brain, I had the 3 and 10 working out, but you can't get the signs to work out. So, beware. Easy mistake to make. 15 and 2 is what we're going to have to use to make the signs work.
Okay, so, okay.
If it multiplies to be negative, one of them's negative. If it adds to be negative, it's a negative 15. So, remember we're going to use those two to split the middle term. 6x squared will carry down. Minus 13x is going to split into the minus 15 and 2. I'm actually going to put plus 2x and then minus 15x. And then I'm going to carry down the minus 5. So we split that middle term. Once you have 4 terms, split it in half. GCF of 6x squared plus 2x.
What about 2x?
Okay, GCF of 2x. When you factor out 2x, what remains?
3x. 3x. Plus 1.
3x plus 1. GCF of the back half. GCF of negative 15x minus 5. minus 5. When you factor out that minus 5, I'm left with 3x plus 1. Remember, this is good news, yes?
Yes.
So my parentheses match. Now, when you write this factored answer into two parentheses, one of them is your GCFs
2x minus 5.
of 2x minus 5. The other one is the
3x plus 1.
matching parentheses of 3x plus 1. Okay, so we had to do a little side work on that one. I didn't dare try and have you guys go through product of AC without writing it down, though. I knew better. So, 2x minus 5 and 3x plus 1 are my denominator on my first fraction. Okay. Times. Now, I didn't talk about it at the beginning. We're multiplying by a not fraction. How do I multiply by something that's not a fraction? Right. How do you make something that's not a fraction into a fraction? You put it over 1. Okay. So, need to talk about that. First factoring step for this numerator. What do you see?
Well, oh yeah, I'll have an X in common.
GCF?
Yeah.
Factor out that GCF of x. So if we factor out the GCF of x, what remains in the parentheses?
2x squared minus 3x minus 5.
Okay. Continuing along. Am I done with factoring on that one?
No, you gotta do product AC again.
Okay, product of AC. I told you this problem has the most factoring probably of all the problems we'll do today. So now, don't forget, what must you carry down out front? You've got to carry that x down, yes?
Yes.
And then we're going to factor what's in the parentheses.
Yeah, I get negative 10, so that's where
So I'm going to factor the 2x squared minus 3x minus 5 using product of AC. So this time it's a product of what? 2 times negative 5, which is negative 10. And a sum of negative 3. Not nearly as tricky as last time.
Oh my god.
What multiplies to be negative 10 adds to be negative 3. Negative 5, positive 2,
Oh, doggone.
right? Some look to me. Do I have this right?
Wait, what did you
Yeah.
do? I can't
Okay.
see. Yeah, I reckon you're good.
Okay.
And it'll turn it into 2x
I'm going to
squared.
bring my first term down.
2x squared.
2x squared.
Plus 2x.
Split my middle term. Gentlemen, focus.
Plus 2x minus 5.
Now, I'm splitting my middle term into the minus 5x plus 2x. I am going to put the plus 2x first, then minus 5x, and carry down the minus 5. 4 terms, we're going to split it in
I am.
half. GCF of the first half. (2x). If you factor out 2x, what remains?
X plus 1.
X plus 1. GCF of the back half. Negative 5x minus 5 has a GCF of negative 5. If we factor out negative 5, we're left with
X plus 1.
x plus 1. Again, good news when my parentheses match. So one parenthesis is the 2x minus 5, GCFs. The other parenthesis is the matching x plus 1s. And those are going to go here on top next to the x we already had. Okay, guys. We've done all the factoring we can. What cancels?
2x minus 5.
2x minus 5 in the denominator cancels with 2x minus 5 in the numerator.
Yep.
Anything else?
Nope.
Okay. Unfortunately, no. That's as far as the canceling can go. Now, when you put your answer, remember we multiply the fractions together, right? Multiply top times top, bottom times bottom. The one thing I will say on top is that in the front of each fraction, we have x and x. I would encourage you to put those together. What is x times x?
Squared.
X squared. And then after that, I'm just going to write x plus 2, x minus 2, x plus 1. All over 3x plus 1. Okay?
And that.
They're never going to want you to multiply factors back together. Yes, something like x times x can become x squared, but other than that, they want you leaving things in factored form. Okay? Now, don't forget, we were practicing doing restrictions on the variables yesterday, right? How are we doing restrictions on the variables?
Denominator didn't move.
Okay. You were taking any and all denominators and setting them equal to 0. Your factored forms, yes? So what factors were ever in my denominators? Well, there's a 3x plus 1 in my answer, right? But before we canceled stuff, there was also a 2x minus 5. Okay. What are my restrictions then? Or do I need to solve these out? We subtract 1. We'll have 3x equals negative 1, and so x cannot equal negative 1/3 when you divide. If we 2x minus 5, if we add 5, we'll have 2x equals 5 and divide. X cannot equal 5/2. So we have x cannot equal negative 1/3 and 5/2. Okay, guys. I told you, I'm trying to give you a variety of factoring review, yes? Yesterday we did some GCF, we did product and sum, we did a little factoring by grouping. One of the big ones we did not get to yesterday was product of AC. I know it's one of the hardest for you guys, so you've got to work on knowing how to do product of AC. Okay, that is one that we need to know what to do on. Questions here? Okay. One more multiplying, then we can divide. On D, a fraction times a non-fraction. Well, what did we just talk about that non-fraction? Put it over 1. Now, with that in mind, guys, okay, good news. Factoring is better on this one, yes? Have you looked at it?
Yeah.
If you didn't like the last one, give this one a chance because this one's a little bit better. What about x squared plus x plus 10? Is there GCF? No. So what factoring technique are we going to assume we want to use? Two parentheses thing, what I call product and sum. So what do I need a product and a sum of?
Product of 10.
Product of 10 and a sum of 1. What multiplies to be 10 and adds to be 1? Nothing?
Solid question.
And the answer is not possible, right? Okay, guys, I know it's a crazy thought, but I had to throw one in here because I saw one in homework. it doesn't factor. Okay?
But
X
that's what y'all
squared?
do.
Plus x plus 10. You guys are all giving me this look like, what just happened? It doesn't factor, so you carry it down as is. When I was going through homework examples and checking out all the dips, I wanted to make sure I had all my bases covered on the factoring. There was one like this. It didn't factor. So you just need to know, okay, that happens on occasion, just carry it down. Okay? Okay. What about x squared minus 49?
That x plus 7 and x minus 7.
Okay, difference of squares. X squared is x and x. The square root of 49 is 7. Multiplying to be negative 49 plus 7 minus 7. What about x squared plus 9x plus 14?
Turns into x plus 7 and x plus 2.
Product and sum? Okay. Multiplying to be 14 is 7 and 2. And those numbers also add up to be 9. And then all over 1, it just stays over 1.
X plus 7.
Okay. What cancels?
X plus 7.
X plus 7 on top cancels with x plus 7 on bottom. What else cancels? Nothing. So, put it all together as your final answer. One factor is going to be x squared plus x plus 10. Put it in parentheses. It's a factor. It didn't factor any farther, so it's one of our factors. We also have a x plus 2 over an x minus 7. And
Oh, restrictions. You can't forget about those.
what about my restrictions? What restrictions are we going to have, guys?
X plus 7.
Yeah. We had factors of x plus or minus 7, so set each part equal to 0. X can't equal negative 7. X can't equal positive 7. I don't know if Savas would let you do it, but I'd be happy with x cannot equal plus or minus 7. However, if Savas doesn't let you do that, it's 7 comma negative 7, right? Okay, guys.
Will that be on the test?
What?
One of the questions where it doesn't have the can't factor.
Not a clue. I say not a clue because I haven't written the test yet. Fair enough? You're not liking it just because
Well, it's just like a situation where if I was doing it, and
you get frustrated because you want it to factor.
yeah, but if I did it wrong and I was like, oh, I can't factor, then I would look at it can't factor. And I would be wrong. But if I know that one of those isn't on there, I know that that's wrong, and I can fix it.
That's what you're saying. Yeah, I don't know. I can't really answer that because I haven't written the test yet.
Okay.
So now, to be honest, when I came across that question in Savas, I was kind of surprised because I feel like they usually do factor. So, okay. Backside. What's the difference in the backside?
Division.
Division.
Yes.
Okay, so multiplying fractions,
Yes, ma'am.
we multiply across. How do we divide fractions?
Well,
Keep, change, flip.
Keep, change, flip?
and then you just multiply it.
Does that sound familiar?
Yes, ma'am.
I taught keep, change, flip as one of my options when I taught middle school. Or multiply by the
Here, we'll just do
reciprocal?
real quick.
Okay, those are the two options I've taught.
Yeah.
Is officially, if you want the mathematic words, to divide fractions, we multiply by the reciprocal. Now, keep, change, flip though, great way to remember it. So, I would encourage you to write something on your paper in case you need to. Multiply by the reciprocal, or if you prefer, keep, change, flip. And I'll be honest, I usually teach both, so. So before I start any factoring, now, when you guys do this on your own, you can factor and do your keep, change, flip at the same time. Me personally, I'm going to teach that we're going to do our keep, change, flip, and then I'll do all my factoring. So when we say multiply by the reciprocal or keep, change, flip, that means I'm going to keep my first fraction as is. So I'm going to keep 3x cubed plus 6x squared plus 3x over x plus 2. What am I changing? I'm changing division to multiplication. What am I flipping? The second fraction. And it is always the second fraction you flip. Always, always, always. So I'm going to flip and say that this is x plus 2 over x squared plus x. Okay, so when we multiply by the reciprocal, it's always the reciprocal of the second fraction. Reciprocal means to flip the fraction upside down. Now, we're back to the front side, aren't we?
Yep.
Okay. What factoring do you see on that first piece?
You can divide by 3x.
GCF? So if you're kind of freaking out about possible product of AC, check that GCF first. They all have an x in common. They also all have a 3. So if I factor out a 3x, I'm left with x squared plus 2x plus 1.
Oh, really? It's 3x and then parentheses, x plus 1. And then
Okay. Is that factoring done there? Technically, no. And if you have a different way you want to write it out there. It's not done because x squared plus 2x plus 1 continues one step farther, doesn't it? X squared is x times x, multiplying to be 1. Not a lot of choices, guys. Not when we're talking whole numbers. Multiplying to be 1 is 1 and 1. Adding to be 2, they're both positive. Okay. Numerator is factored. What about that denominator of x plus 2?
I don't know.
No GCF. It's already linear. X plus 2 just stays x plus 2. What about my next numerator? What about x plus 2? Well, it didn't factor a moment ago, so guess what? It's still not factoring. What about x squared plus x?
Stays the same.
Not quite.
Isn't it just x plus 1 and x plus 1?
No.
Well, I can't tell you. X plus x plus x. That's what I'm saying.
Was that x plus x?
X times x plus x.
Closer.
X.
So
X cubed.
think in terms of GCF here. There's two terms. Do they have something in common?
You divide by x. And
You
you
divide
get
by-
x plus 1.
Okay, so if I factor out a GCF of x squared divided by x leaves me with x, plus x divided by x leaves me with
X plus 1.
1. So for this second fraction, I have x plus 2 over x plus 1.
So wait.
What cancels?
X plus 1, x plus 1, and x plus 2, and x plus 2.
Okay. X plus 2 in the denominator cancels with x plus 2 in the numerator.
X plus 1.
And x plus 1 in the denominator cancels with n x plus 1 in the numerator, right?
Can that
1 for 1 deal.
Can that x get rid of the x and the x?
Okay.
Yes.
So yes, the other piece you have to do here, an x in the denominator will cancel with a plain x in the numerator. Well, remember, 3x is the same as saying 3 times x. And since those are multiplying pieces, yes, you can cancel just part of it. So x cancels with x. What do I have remaining for my answer?
X minus 1.
Except why are we all saying x minus 1? Oh, okay. I heard a couple of minuses. It seems like it was spreading. So don't forget, I almost overlooked it, to be honest. There is a 3 out there still, yes? So there's a 3, and there's an x plus 1. Nothing else left on top, nothing left on bottom, so 3 times x plus 1. Now, forgot to check. I'm not sure you ever have to do restrictions on division problems. However, I want to talk about it real quick. When we talk about restrictions, what have we been doing for restrictions on the variables? Setting denominators equal to 0, right? With that in mind, when we set denominators equal to 0, well, here's what I'm going to say. Anything that ever was or is a denominator. What pieces do you see we should be saying equal to 0?
X plus 2, X, and then X.
X plus 2,
X.
X, and X plus 1. Now, that's looking right here, yes? X plus 2, X, and X plus 1. Officially, and it doesn't end up mattering this time, but besides looking at these pieces, you also need to go back up to what was originally in the denominator here before it got flipped. Now, that's an X plus 2, but what do we already have? We already have another X plus 2, don't we?
So wait on the next one, though. 3,
So in the next one, it could make a difference. In other words, this one, we already have it, so it doesn't matter. But one, you've got these, but then also anything that was in the denominator originally before you flipped. So, what can X not equal? -2, 0, and -1? Okay. I don't know if okay. Let's at least do B, so we can practice division. We may or may not do C with your class. We'll see.
I prefer not. Is there a difference in the fact that B and C are in parentheses? It's not
Nope, no difference.
either way they do
Tricky.
Well, they would be me, but it was honestly probably the problems I was taking from the book or online or wherever. Nope, you could have parentheses, you could not have parentheses. No difference. Just making you think, I guess.
Okay.
Okay, guys, B. What type of problem is this? Division. What must your brain think if it's a division
Keep
problem?
change flip.
Multiply by the reciprocal.
Okay, either of those. Keep, change, flip, multiply by reciprocal. So I'm going to keep 1 over x squared plus 9x. I'm going to change division to multiplication. And I'm going to flip.
3x plus.
Make it 3x squared minus 18x over 6 minus x. Okay. I'll take the numerator for you.
Oh, thank you.
1 is 1.
Appreciate that.
You're welcome. X squared plus 9x.
Well, you go ahead and square root her.
Divide by X.
Oh, yeah, no, divide by that.
Let's think GCF here.
I'll go on it.
I don't want to square root it for 2 reasons. 1, there's an x with a 9. And 2, it's a plus, not a minus. Okay? So GCF of x leaves me with what? X plus 9. Okay. Numerator. 3x squared minus 18x. What do you see? There's an x squared, there's an x term, so think
So 3x on the other side.
GCF of 3x. Yep. We factor out 3x, what goes on the inside?
X minus 18.
Dang it,
X.
oh,
X minus 6?
Yep.
Divide them both by 3x. Okay. Now, I don't remember if you'll see one like this in homework or not, but I know I always see this in my past books.
Okay.
That denominator, 6 minus x.
Just leave it.
What's unique about it?
It's flippity floppity.
Okay, it's flippity floppity, in Landon's words. Now, my suggestion is that you unflippity floppity it.
Just ignore it. Times it by.
Now,
Can we do that?
I can't times it by anything, but
You just flip it.
we're going to factor it is what's going to happen. So now, when I flip it, first of all, if I flip
Is
this,
it just negative x plus 6?
it's negative x and then positive 6, yes? Now, here's the deal. That is oh so close to being x minus 6,
Very
but it's not. There's a difference of
numbers.
a negative sign.
Yep. Oh.
Factor out a negative 1. If you factor out a negative 1, negative x becomes positive x, and plus 6 becomes minus 6.
Shucks. Look at that.
Okay? So when you see something that's backwards, I would encourage you to flip it. And then if it's worthy of factoring out negative, because something will cancel, do that. What cancels? X minus 6 with x minus 6. And x with x. What remains?
3, wait,
3, negative 1.
no. 3 over negative 1 x plus 9. Oh, yeah. That works.
3 on top. There's a factor of negative 1. And there's a factor of x plus 9. I wrote mine as negative times x plus 9. I'm not against you putting a negative 1 there. I'm also not against you moving the negative up top to be with the 3. I don't know how picky Savas would be, but.
Well, Savas.
Okay, guys. Restrictions on the variable. Remember, its denominator is equal to 0. And when we talk division, I always say old and new denominators equal to 0. Okay. What pieces am I setting equal to 0?
X plus 9.
X plus 9,
X minus 6.
x minus 6.
Negative 1, 0. Which is not number.
Negative 1 is just a number, so that's not going to matter.
Okay, so then x.
X matters because it's a variable.
And then your 3x squared minus 18x.
Okay, so we got x plus 9, we got x minus 6. Officially, we need to talk about 3x squared minus 18x. What did that factor into? It factored into those pieces, right?
Well,
So officially, I should say 3x, and I should say x minus 6. Well,
we have that, so.
We already ended up with both of those, so it's not going to, honestly, neither of those two are going to matter because they will end up matching with other pieces. But that's what you need to consider, okay? So, x cannot equal what?
Negative 9.
Okay?
Positive 6.
Uh-huh.
0.
0. Negative 3.
If this is 3x, this would just
Divided by 3x.
divide by 3, and that would be another
0.
0, and then that one would be another 6. So you just end up with negative 9, 6, and 0. Now, time-wise, I'm almost tempted to just do the last one because I'm not sure would you guys even start working on homework.
I can't do the
I
last
already
one.
finished the last one.
So,
I would start.
I think we're done.
It looks about the same.
Okay, here's the deal. I'm going to go ahead and go through C.
Oh, that's,
I'm giving you guys the option. Follow along with me or work on homework.
Alright.
But it's one of those two options. There are no other options, okay? You're either with me or you're starting on the homework. Okay? And I'm doing this because I want to put C on the recording. So
Okay.
that's why I'm going to go ahead and do it. Division. Since it's division, I'm going to keep change flip. 2x squared minus 12x over x plus 5 is going to keep. Change division to multiplication. And I'm going to flip and make it x plus 5 over x minus 6. There's actually not much factoring on this one if you tried it. On top, GCF of 2x squared minus 12x is 2x. Factor out the 2x, I'm left with x minus 6. X plus 5 stays as x plus 5. The next x plus 5 stays as x plus 5. And x minus 6 stays as x minus 6. This one actually worked out really easy. What cancels? X minus 6 with x minus 6. X plus 5 with x plus 5. What remains? Just 2x. And then if I talk about restrictions on the variables, anything that ever was or is a denominator. X plus 5 equal to 0. X minus 6 equal to 0. And if you look back up to the original, there was another x plus 5 equals 0. So we end up with x cannot equal -5 or 6. Okay. If you haven't already started, you've got a couple of minutes. Lesson 4.3 in Savas, and it is due tomorrow. Or at least that's what should be listed. And then tomorrow we can start adding and subtracting. Let me know if you guys have questions.